Hey guys, this is Mrs. Elliott, and these are your 5.4b notes on factoring quadratics. This is part 2 of the factoring lesson, and we split it into 2 parts because it can be quite complex. And today we're going to be focusing on 3 things. We are going to be focusing on the difference of two squares, perfect square trinomials, and then factoring when that leading coefficient is not 1, when that number right there is not the number 1, okay? So let's go back up to our difference of two squares. I think these can be some of the absolute easiest problems. It just is going to require you to recognize the pattern. A difference of two squares is exactly that. It's a square minus another square. If this had a length of b and this had a length of b, and I guess I should say a. So let me start that over again. So this guy, I'm trying to do the little square option there. Okay, that looked a little better. If this guy had a length of a and this guy had a length of a, and this is a b and this is a b, the area is actually a times a, which is a squared, and the area of this one's b times b, which is b squared. Well, that's a squared minus b squared. That's exactly what we're doing. We're taking a square and we're subtracting another square. When you do so, it actually factors into the following: a minus b and then a plus b. If you went and did FOIL, first, outer, inner, last, it would turn out to equal this right here. Why? Because the middle two terms cancel out. You get a squared, you get positive ab, then you get negative ba, and then you get negative b squared. And these guys cancel right there, okay? So that is why it works. Now let's just skip straight to the answers. And here's how you do it. Ask yourself what squared is giving you 64. This is your A, okay? Well, what can you square to get 64? 8. Then you ask yourself, what can you square to get x squared? This is going to be your B of the formula. Well, x. X squared is x squared. So now this is technically this, okay? A squared minus b squared, and we can just throw it straight into the little formula here. 8 minus x, 8 plus x is our answer. You'll get to where you can just do this instantaneously. You're just going to see it. I love throwing up just examples like this and getting students to just repeat the rule very quickly to me. And so I'll do that to you guys real quickly. This would turn into this. This would turn into this, and so on. You could just keep going. You can see how quickly I'm getting to my answers there. I see it's 9. Oh, 3 and 3. I see 16. 4 and 4. I see 25. 5 and 5. One's negative, one's positive. Okay? So let's look at our next one. When they're not so straightforward as these over here, I asked myself, what can I square to get 36? Well, I can square 6. And I want 36x squared, so I need an x there. What can I square and get 100? I could square 10 and get 100. So filling them in, I've got 6x minus 10 and 6x plus 10. Okay? Now, if you're sitting here and you're looking at that, you might say, wait a second. I've got 6x, I've got 10, I've got 6x, I've got 10. Those are all divisible by 2. Well, you would be exactly right. So we are actually going to go back to the beginning of that problem and rethink it. What did we do wrong? Okay, and I did this for a reason. So what did we do wrong? We forgot the GCF. You should always look for a GCF no matter what first, okay? No matter what. So let's go back and look for a GCF. What are both of those divisible by? Well, they're both divisible by 2. They're actually both divisible by 4. So maybe let's try 4. If I divide both of these by 4, I factor out of 4. So I'm going to put the 4 right there. It's been factored out. And I'm left with 9x squared minus 25. Do 9 and 25 have a GCF? Nope, they don't. So now I'm going to redo my problem, making sure to put a 4 on the outside. So what could I square and get 9x squared? 3x. 3x squared would give me 9x squared. And what could I square and get me 25? 5. So my answer is actually 4 times the quantity 3x minus 5, 3x plus 5. and that is much better, okay? So next, is there GCF here? Nope. So we are going to go ahead and just break it down. We know that a number that we could square to get 25x squared is 5x, and a number that we could square and get 121 is 11. So I'm just going to go ahead and put 5x minus 11, 5x plus 11. And it doesn't matter where you put the plus or your minus. I'm just putting the minus first because that's what the formula on the notes say. But if you did plus first and minus second, it's not going to matter. All right, looking at the next one, is there a GCF? Yep, they're both divisible by 3. So factoring out of 3, I'd be left with x squared minus 4, and this one's pretty easy. It's kind of like one of these right here. I'm just going to split it up into the x plus 2, x minus 2. And see, I put the plus first that time because it doesn't matter. So let me go ahead and circle all of our wonderful answers that we got. And let's move on to perfect square trinomials. Perfect square trinomials are very similar. They have a nice little formula, and it can be very quick to find your answers. You just want to make sure that when you're doing a perfect square trinomial that this middle term does in fact work out. So let's jump straight into an example so I can explain. Okay, looking here, I've got a perfect square in the leading term and I've got a perfect square at the end here. Okay, what squared would give me x squared? Well, x squared would give me x squared. And right here, 4 squared would give me 16. So you have to ask yourself, look, according to the formula, we should be able to double a times b and get our middle term. So if I doubled x times 4, okay, my a here was x and my b here was 4. If I took a times b and got 4x and I doubled it, would I get this middle term? And I would. So it does check, and I can go ahead and write it like this, and my a was x and my b was 4, and I square it, and I'm actually done. Boom, straight to my answer. If you do have a negative right here, the only difference is you'll have a negative right here, because you have to consider the fact that one of the terms is negative, and when you double it, you have that middle term of a negative, okay? So when it's positive right here, it's positive right there. When it's negative right here, it's negative right there, okay? So what could we square and get 4x squared? 2x. What could we square to get 9? 3. If I take this guy and multiply them by each other, I get 6x. And if I double it, do I get 12x? Yes, I do. And because I have a negative right here, I know to just put a negative in the middle of the two. So 2x minus 3. And that's all you do. Okay, factoring when a does not equal 1. These can actually be pretty tricky, but we are going to do this in a method called factoring by grouping. And when I come back to class, I'm actually going to show you lots of different methods, but for right now, we're going to stick to this one method because these notes could be really, really long if I did all the different methods right now, okay? So we are going to factor 2x squared minus 5x minus 12 completely. So pre-step, if needed, factor a GCF out. And I've told you guys that. That's always should be your first step. Well, 2, -5, and -12 do not have a greatest common factor other than 1, which we don't really consider greatest common factor because it's an identity. So we're going to go ahead and get started without factoring out a GCF. So the first thing you're going to do is multiply a times c. So these outside two terms, knowing that that's a and that's c, that's your a times c. So 2 times -12 is -24. Then I want you to find two numbers that'll multiply to give you AC, whatever AC was, and here it was -24, and also add to give you B. Well, looking back at your problem, what is your B? It's -5. So let's go through our factors of -24, and we're looking for two numbers that'll add to give us -5. And honestly, as soon as we come across it, we're going to circle it and we're going to move on, okay? So -1 and 24, +1 and -24, -2 and +12, +2 and -12. Still don't see anything that adds to give me -5. -3 and +8. Oh, we're close. Or +3 and -8. I think we've got it. So right here, +3 and -8. Those do, in fact, multiply to give us -24, but they add to give us -5. So now I'm going to rewrite the expression with the middle term now split into these two terms. So 2x squared, just bringing it down. But instead of writing negative 5x down, I'm going to write 3x minus 8x. Do you guys agree that's actually negative 5x? Yes, but I've represented it in such a way that it's going to allow me to factor this expression. And I'm going to go ahead and bring down that negative 12. Now I'm going to factor the GCF out of the first two terms and the second two terms. So we're first going to focus on these first two terms, okay? So looking just at these two guys, and then we're going to look just at these two guys, okay? So looking at the first two terms, what's the greatest common factor? They both have an x, okay? And I think that's it. So I'm going to rewrite now what's left over. A 2 is left over, and an x is left over in that first term. And if I take an x out of the second term, the only thing left over is a 3. Now we're going to focus on the next two. They both have a negative. I'll go ahead and pull that out. And 8 and 12 both have a factor of 4. They both do not have an x, so I can't pull an x out. So I'm going to go ahead and close that. If I factor a 4 out of a negative 4 out of negative 8x, I'm left with 2x. And if I factor a negative 4 out of negative 12, I'm left with a positive 3. And what would you look? These two terms now is say this is one big giant term and this is one big giant term. Both of those giant terms have a 2x plus 3 in common. So I'm going to go ahead and factor out the 2x plus 3. If I factor out the 2x plus 3, what's left over? All the x is left over, and then my connector is a minus, and the 4 is left over. That is my answer. 2x plus 3 times x minus 4, if I FOILed that back out, would equal that. Okay? So let's do these last two examples, and then I'll let you guys get started. Okay? So first we're going to look for a GCF. Yes, this one does have a GCF. Looks like they're all divisible by 2, so I'm going to divide every one of them by 2, and then make sure that 2 is part of my final answer. So 6x squared plus 13x plus 5. Okay, I'm going to multiply a times c, and when I do so, I get 30. Okay, so that is my AC. So now I'm looking for two numbers that'll multiply to give me 30, but will add to give me 13. Sorry. Okay, that'll add to give me 13. So let's start listing out our factors of 30. We've got 1 and 30. We've got 2 and 15. We've got 3 and 10. Oh, there's my winner, 3 and 10. All right, so fill it in. 3 times 10, does that equal 30? Yep. 3 plus 10, does that equal 13? Yep. So I'm going to go ahead and write my 2 down. Then I'm going to write my 6x squared, but then I'm going to split that term into 3x and 10x instead of writing 13x. It still equals 13. It's just split into 3 and 10. And then I'm going to write down my 5. Now I'm going to factor out the GCF of the first two terms, and then I'm going to factor out the GCF of the second two terms, and I will be very close to being done. Okay, so here's 2. They both are divisible by 3, and they both have an x. Okay, what's left over? X and nothing. So we put a 1 down. Okay, because we have to write something down, and if you factor everything out, you're left with the identity of 1. Next, they both are divisible by 5, and that's it. And I've done something, and I'm in the middle of my notes, so I can't really stop. Okay, so ideally we should be getting a 1 plus x plus 1 here. And I can't pause my video, so I'm just left feeling silly right now. You guys can probably picture me in the middle of the class, this happening. And I'm looking back over everything. I think we've done everything correctly. We divided everything by 2. 6 times 5 is 30. And we got that middle term of 13. There it is. There it is. Yay, there's a 2 right here. If you caught it before me, you're probably screaming at the computer screen. That's okay if you were. It's been a long day, folks. I had about 2 hours of sleep, so I think I'm doing pretty good. Okay, since there's a 2 there, hopefully you guys see what I was looking for. Those middle 2 parentheses should match. There's the 2 there. We got it. Okay, so when I factored out my 3x, I forgot to write down a 2 right there. And we've got the 2 right there now because 5 times 2 is 10. I feel so much better. So writing down our 2 on the outside, what did both of these giant terms have in common? They both had a 2x plus 1 in common, didn't they? And then what was left over after I pulled out the 2x plus 1 they both had in common? Well, there's a 3x and there's a 5. 3x and 5. And we are finally done. Okay, tell Miss Elliott to go to sleep. All right, one more problem. We're going to factor a 2 out of everything. So we're going to divide everything by 2. And 2 remains on the outside. So we've got 6x minus 17x minus 3. Okay, got some minuses in here. So we're going to have to kind of think a little more. I think when they're all positives, it tends to be a little easier because you're not dealing with negative positive combinations. All right, multiply the outside 2 numbers by each other. 6 times negative 3 is negative 18. So I'm looking for 2 numbers that will multiply to give me negative 18. That will add to give me that middle term of negative 17. Okay, so list out the factors. We have negative 18 and 1. Oh, that's it. It didn't take us long. Negative 18 and 1 works, right? Negative 18 times 1 is negative 18, and negative 18 plus 1 is negative 17. So I'm going to rewrite this, splitting up that middle term. I'm going to split it into negative 18 and positive 1, and then bring down that minus 3. Now I'm going to factor out the GCF of the first 2, and then I'm going to factor out the GCF of the second 2. Now remember, I'm looking for 2 large terms that each have a common factor in those parentheses. So things should match up as you work through these, and hopefully you can catch things like I did. I knew I'd made a mistake because the 2 insides were not matching up. So it's good to know that, because if you don't know that, you wouldn't have known I was making a mistake, whereas I did. Okay, you can divide both of these by 6, and they both have an x. 6x squared. I only took one x out, so there's one x left there. And then I've got a 3 left over here because 18 divided by 6 is 3. And then here I'm going to not factor anything out but a 1. How do I know that? Because I know I'm trying to match that guy. And I can easily match that guy by putting plus 1 and then just writing what is there. Okay, because 1 times that would equal x minus 3. So there we go. I've got a big term here. I've got a big term here. And they both have an x minus 3 in common. So I'm going to go ahead and pull that x minus 3 out. And what's left? 6x plus 1. And we're done. Okay? Just one quick note. At the end of our notes yesterday, there were some students that did have some questions on those last 2 problems. Those were GCF problems. I do want you to know that not every problem can be split into 2 binomials like this. Some problems are just a good old GCF problem, like this one. And that's what those 2 problems were. You weren't supposed to do any factoring into 2 binomials. You were just supposed to factor a GCF out. I hope this has helped. I hope I didn't confuse you all too much. If you have any questions, please email me. And you know that I'm going to get you on the same page when I come back. We will factor for a few days and we will get this right. Hopefully I will see you guys soon. Thanks.